Hi, my ducklings. Today we're going to do probability, and it's without replacement. We also call conditional probability. Well, let's start. Question 1. There are 28 men and 36 women at a party. Of these, 10 men and 14 women are married. If 2 people are chosen at random, find the probability that A, both will be men, B, one will be a married woman and the other one is a non-married man. C, both will be married. Now, this is a without replacement question, as I mentioned. Now, what the without replacement question means, really, we can safely say this is the default in probability questions, unless the question specifically says with replacement. Also, without replacement means once an item is selected, it is not put back before the next selection. So the total number of items will reduce each time. Oh, our question. Now, I wouldn't draw a tree diagram for this question because it has overlapping categories like men, women, married, unmarried. It's too messy and complicated. So I will use a two-way table on the screen. So put everything together, the information, onto two-way table. From the question, we have 28 men. My total for men is 28. By the way, two-way table is normally 2 by 2, but it's a good idea to put the total on each end. Now, how many women do we have? 36 women. So I'm going to go to the end, 36 here. And what other information do we have? 10 men are married. So I'm going to go to married and a men. I'm going to put 10 there. Now, automatically, that applies. Unmarried will be 28 take away 10, it'll be 18. And then there are 14 women are married, so I'm going to put 14 here. And unmarried will be 36 take away 14, it'll be 22. Now, let's put all the total. So there are 24 married people and there are 40 unmarried people. And altogether, 64. And also, these need to match up to 64. These two add up to 64. And I think we are quite safe. So this is what we're going to use. I wouldn't use tree diagram, too complicated. But two-way table is simple in this case. Okay, so now I'm going to look at part A. So probability of selecting first men, and the second selection or pick is men as well, because we're going to pick 2 people. So this is in the same branch, so I'm going to times them. And we started with a 64 people and 64 people. And how many men are there? There are 28 of them. So I'll write 28. So we have a 28 choices to pick, and then second pick, because I already picked first, 63 of them I have to pick from. And then there are 27 men are left to pick. So I could just rewrite. You don't have to rewrite like this, but I just want to show you. You can, and put that in your calculator. You will get 3/16. Now, of course, you can express this in decimal 0.1875 or in percentage 18.75%. But we are going to just stick with fraction 3/16. Question. Very good. As I explained earlier, it's a without replacement and the total will be reduced each time. So the first man was selected from 64 in total. So for the second man, there'll be only 63 people left in total. That's why the denominators are different. Good question. Let's go to part B. Part B. Find the probability that one will be a married woman and the other one is a non-married man. So I put the two-way table nearby so we can use all the information. So probability of one person is married woman and the other person is non-married man. Now there will be two cases, wouldn't it? So if I pick married woman first, and then I'll pick non-married men. So I'm just symbolizing it, capital M for married and capital M with a bar on the top as unmarried. And then plus I will have second case, which I pick unmarried man first and then married woman second. So there'll be two cases we have to deal with. So there's two branches if you think about it. And so each branch you times it. But if it's in a different branch, which means different case, we will plus it. First case is always from the total. So 64 is our total. So I'm going to put it as a 64 for our first pick. And I'm just going to write second one as 63. We know now why the second pick is 63 because one less. And married woman. So let's have a look. I'll go to married and a woman. 14. Okay, so I'll put 14 there. And then unmarried men. So I'll go to unmarried men. So it's 18. So I'll put 18 there. And it's just swapped. So I'm just going to put 18 first and a 14 because we're going to pick unmarried men first. Now this is really, if you think about it, exactly the same because you're just timesing it, right? So it doesn't really matter if you put 14 times 18 or 18 times 14, same thing. And what I can do here is 64 times 63. I'll just double it. Then when you put that in your calculator, you will get 1/8 as my answer. Okay. Obviously, you don't have to do all this writing for working out. You just put it in your calculator from here if you want. Okay, so next question. Part C, find the probability that both will be married. So I will still use the two-way table here and finding a probability, capital P, and both married. Now, good thing about using the two-way table, you don't have to do that 4 cases like married man, married woman, 1 case, and then swap around second case, and then married woman, or married man. Because it's two-way table, makes everything quite simple because this is just one branch. So we don't have to do the cases, doing 4 cases together and add them all up. We don't have to do that. So I'm going to put that as a 1 branch. So still same, we're still gonna have 64 people to choose from for the first pick and then 63 for the second pick. Now let's have a look at how many people are married. 24 people are married. So first we have 24 choices to pick one person who are married, and then on the second pick we will have 23 people to choose from. And of course you don't have to do this step, but I'm just going to do it to show you. And the answer will be 23 over 168. And that's my answer. Well, that's all for this video. Hope it helped. And don't forget to like and subscribe. See you next time. Bye.